All right. Well, my name is, good morning, everybody. My name is Ellen Goodwin. I am Infrastructure Manager at New Anglia LEP, but I'm also leading on the Clean Growth Task Force strand of the organisation. And one of the things we've been doing over the last 3 or 4 months is running a series of webinars and events very similar to this one, very informal, called Clean Growth for Business, really focusing on disseminating information, networking, and really understanding what the area is doing and what we could be doing, and really sharing that best practice amongst people within the area and wider. So today we're going to hear from Connected Energy, Suffolk County Council and the University of Suffolk, who are going to tell us a little bit about a project they've been working on at the Hold in Ipswich. I think from my point of view, the Local Enterprise Partnership is very much supportive of local energy projects and projects like this. So when we heard all about it, we thought it would be great to kind of raise its profile with you guys. So I'm going to hand over now to Matthew, who is the CEO of Connected Energy.
Good morning, everybody, and thanks for that introduction. We're going to show a video very shortly, which sort of gives a bit of background on Connected Energy and what we do around our energy storage systems. But I just wanted to perhaps provide a little bit of an introduction to the broader business before we show you the detail. And I'd like to firstly say thanks to the people in the Anglia region and Suffolk Council and West Suffolk Council and the university for deploying our technology, because we're a startup based in Hethel Innovation Centre just south of Norwich, and we've been developing some technology which we are being told is world-leading technology. So you have some world leaders in your region, albeit we're fairly small at the moment. And basically what we do is develop energy storage systems that use second life electric vehicle batteries. So those are batteries that have been depleted through their use in electric vehicles, and then we take them and we convert them into stationary energy storage systems. We've been operating out of Hethel for I guess about 5 or 6 years now, and are really now concluding a fairly major investment round to really start to scale up the business in the UK and overseas. And the key problem we're trying to solve is that as these batteries are degraded through electric vehicles, there will be huge volumes of these batteries available, but their use in the vehicles doesn't really capitalize on the full value in them. So they still have half of their working lives available. So our role is to figure out how to capitalize on that value. And then running in parallel, as we decarbonize the grid and we install more and more non-dispatchable renewable generation, there's a technical requirement for energy storage to manage that availability of energy, and also to provide resilience on the network. So we're sort of bridging the gap between this availability of batteries and the technical requirement for energy storage. So in terms of our business strategy, our focus for the next 3 years is to really scale up our business and our technology from the kind of systems you're seeing now to systems that are sort of 100 times bigger. And we plan to build one of those systems in 2024. And part of our current investment round is to fund that first large scale project. And then once we've done that, our strategy is to roll out these larger systems alongside the smaller systems, over the course of the next few years as these batteries become available. So we're forging some really good partnerships with OEMs, and we hope to have a couple of OEMs investing in our current investment round. And we hope that you will see a flourishing and exciting business developing in your region, and something hopefully to be proud of. So again, thanks for the support we've received from the region. Thanks for hosting this event. And Nigel, now he's learned how to share the video, we'll share the video, and you'll hear some more from me, but more planned and with some pretty pictures as well. Thank you.
Thanks, Matthew.
At Connected Energy, we're pioneering the circular economy by developing stationary energy storage systems that utilise second life electric vehicle batteries. Based in our Newcastle head office, our team can help you understand how energy storage can benefit your business. We can interpret your site energy system and analyse your load data to determine the most appropriate system size and how it would work commercially. If you decide to proceed with an order, we can then provide a full turnkey service delivering the project. This is our 300 kilowatt, 360 kilowatt hour e-store system that uses 24 second life Renault Kangoo batteries. We've worked closely with our battery suppliers using their knowledge and expertise to help us optimise how we control their batteries. At a point in their lives, EV batteries no longer provide the range required by the driver, but still have plenty of life left in them. We aim to extend their lives by up to 10 years before they're recycled. We use quality checked but unchanged battery packs, which means we capitalise on the investment Renault has already made in the batteries. Our control systems enable large numbers of batteries to be controlled as one aggregated system. We have active cooling systems to minimise degradation and increase efficiencies. We can set and track many data points so the system can be monitored, optimised and maintained, either using in-system HMI or remotely using our web portal. Using this portal, customers can see how systems are performing to help them reduce energy costs and generate revenue. In the control room are housed the inverters which link to the batteries. There are multiple channels of inverters and batteries which come online as and when required, depending on how much power is required from the system. The temperature of the inverters is managed using an active cooling system. There is also a UPS to maintain the system if the power is cut. This is the HMI, which enables the operating parameters to be set and adjusted on site. It also provides information to service engineers. The system can either be controlled by a third party, such as an aggregator, or can respond to parameters set within our microgrid control software. Using a hierarchy of operating rules, the system can charge or discharge according to a schedule, or it can respond to metered points on a site, or a combination of the two. So for example, on a site where the e-store is linked to EV chargers and PV, it could be set to charge according to a time of use tariff, then also charge to respond to the PV generation, then discharge to peak shave the loads from the EV chargers. In this way, the maximum site load is managed and the EVs are charged using low carbon energy generated from the on-site PV. Where possible, the balance of the electricity required is consumed during low tariff periods. The microgrid control software can be used to solve problems such as managing peak loads or to help optimise an overall site energy system. You're very welcome to meet our engineers at our technical centre in Norfolk to learn more. You can see one of our 300 kilowatt, 360 kilowatt hour systems working to provide Suffolk County Council with cost savings at their brand new Hold Archives building. Suffolk Archives collect, preserve and share over 900 years worth of Suffolk's history. Our battery storage system is providing power to the building at times when the grid electricity is expensive and thus helping reduce the fixed energy costs. The battery is also performing in the grid services market through aggregators, who are providing the council with long-term revenue streams which are offsetting the cost of running the new building. Another of our systems is in action at the new Mildenhall Hub development. West Suffolk Council have delivered a range of community facilities including a gym, library and Olympic-sized swimming pool. Our e-store system is providing cost savings and new revenue generation by providing grid services to National Grid. In the future, the battery will charge from a 300 kilowatt solar PV array and offset additional electrical usage from their new heat pump. Our team at Connected Energy looks forward to accompanying you on your sustainability journey.
There we go. Yeah, so I hope everybody enjoyed that. That gave us a very kind of an overview of the two projects, the Hold and also the project with Mildenhall Hub. And now I'm going to pass over to Mark Dale, who can talk a little bit more about the Hold project.
Thank you, Nigel. No pressure there. Right. Am I sharing my presentation on my screen, or has someone already got it there?
Yeah, you can share yours if you like.
Yeah, okay, bear with me. I'm going to just try and... I think I need some sort of permission. I'm more used to using Teams. Oh, I've got a share screen button. Bear with me. Right, there we go. Right, hopefully, can people see a PowerPoint presentation now?
Not yet.
Not yet.
Oh, here it comes.
Up here we are.
Fantastic. So I've got a short presentation just about the whole project based on the Ipswich waterfront, titled The Smart Energy System, Energy Flexibility. One of the main aims is looking at the flexibility of the energy. So a little bit about the background. We've got a picture of the whole building at the front, which we just saw on the video there, and then bottom left-hand corner, we've got the location of the whole building on the Ipswich waterfront. I'm not going to go through all the bullet points, but the Hold was a £20 million building, which was partly funded by National Lottery, and it's located on the waterfront area, which is a kind of a regeneration area as part of Ipswich. And it was a partnership between Suffolk County Council and the University of Suffolk. The aim of the building is understanding the past while looking at future innovation. A little bit about the energy usage on site is purpose-built strong rooms, auditorium facility, as well as exhibition space and cafe and a shop. The battery storage project was born partly out of a feasibility study done off the university and the Hold back in 2018 to look at energy investment opportunities, to look at technologies that we could do to be ahead of the curve, essentially. We looked to pride ourselves as being an anchor institution and look to explore new avenues. So the Hold was first opened in September 2020, right in the middle of the pandemic, but the official opening was September 2021. And now is an up and running building open to the public with 900 years of history being preserved by Suffolk Archives and the Strong Room. So that's a little bit of background of the building. One of the great things about the project was the partnership aspect. It brought together several partners where I've put some logos on the right-hand side. From the project start to kind of when the battery got installed, the council declared a climate emergency. So this work fed quite nicely into that as well. My main role now is decarbonising the Suffolk estate. We've recently had funding approved to look towards our net zero 2030 targets. And more we're looking at reassessing the feasibility in the current energy crisis and the rising cost of energy to see how we can be more efficient about using energy within our buildings, as well as decarbonising, reducing the running costs of the buildings. So a little bit more about the system itself. Obviously, some of this was explained in the previous video. So the refurbished batteries the building, because it's quite an energy intensive building. The battery system is ensuring we're using 100% of the solar PV. We're looking to expand on that PV as well, similar to what they're doing in West Suffolk. And I can't claim responsibility for this because I came on later in the project, but Nigel and my colleagues at Suffolk as well were awarded a RISE Award in 2019 for the innovative nature of the technology. Connected Energy through the process also managed the UK Power Network's export license with us, so we could export to the grid and get everything set up. Also helping to set up the EDF aggregator contract to make sure that we were looking at the site load and kind of optimizing running costs, and also exporting to the grid at peak times, the most beneficial time, I should say. So a little bit more about current performance and future aspirations. On the left-hand side, I've just got a graph of a recent day. I think it's about 2 weeks ago. This is kilowatt-hour energy consumption on site. So the battery was charged first thing in the morning, which you see the sharp peak on the left-hand side. Site load during the day, and then we've discharged the battery at 4 o'clock in the afternoon and essentially taken the building offline for 3 hours, and we've actually been exporting to the grid during that period. So you see it goes down to the minor section there. And then we go back to the standard base load of the building. So the system provides us an opportunity to save on those energy costs during peak periods. Tried in GWOS, which I won't go to much, and PIs are more expensive. So we're taking the building offline, and we're not having to rely on grid energy at that time. What we're also looking to do as part of wider decarbonisation, reducing energy at the building, is the BMS system is going to go up to the cloud. So we're hoping to tie that in with the battery in the future, additional solar as well. And it gives us the opportunity to expand on the electric vehicle charging that's already on site. We know that we've got the ability to discharge the battery and produce additional load or building power when we need it, and we don't have to rely on grid energy for that. So I think that's everything. I'm going to stop sharing now. That was a bit of a rattle through. Does anyone have any questions at that point, or any comments on that? Nothing there, so I'll hand back to you, Nigel.
Yeah, no problem. Thank you, Mark. I'm not sure whether Kenneth was trying to ask a question. It sounded like his audio was coming on. Oh, no. Well, we've got a little bit of time at the end as well for any Q&A. So if anybody's kind of jotting down any notes, or whether they want to ask any questions at the end, then that is fine. Yeah, we've scheduled around about 15 minutes at the end of the hour for Q&A. So yeah, thanks again, Mark, for kind of giving a summary of the project with Suffolk County Council. Also, part of the very same project is a research partnership that we have with the University of Suffolk. That is a 3-year research partnership, and I'd like to pass over to Daryl to expand on that.
So I just need to unmute myself. I had to move myself in the room because my lights keep going off because there's not enough movement going on. So I've had to come onto my smaller screen, which is a nice technical issue. I'm going to try and share my screen now. Give me a second. Can you see my screen?
Yes.
Good. Hold on a second. Come on. Let's go into. So just a brief introduction. I'm Professor Daryl Newport. I'm Director of the Suffolk Sustainability Institute. I'm also Professor of Energy and Sustainable Development within the University of Suffolk. I can't say that I was actually involved in the project at the very beginning. I've actually been at the university for the last 7 months, but actually it's been a great project to actually get hold of as I've come in. So it's a really nice program of work that actually we're looking to develop a lot of research in this area. So not necessarily just battery storage, but also in renewable energy and alternative energy solutions. So I've been really quite interested in how this has been set up and how it actually has been given an opportunity to research the solution that we have in place at the Hold. And it also gives me a great opportunity to look at the teaching capabilities of the university and actually bringing this type of solution into the teaching opportunities. So we are working with Connected Energy on a 3-year program, initially of which they're offering a bursary, which will hopefully assist in developing a leading area of research and hopefully to develop a PhD opportunity in this area for us. But we've got full access to the systems, so we're really interested in evaluating and monitoring the solution that we have in place and the opportunities actually that may link to other areas of the university in terms of the different types of technology and energy production we have going on. So it's our Ipswich campus on the waterfront is progressing. We've got a number of new buildings coming on board, and we've got a number of solutions that we're putting in place, which I think these connect to quite nicely. So it's great that this is happening, and I can see the opportunities developing within our engineering and architecture courses, because those are the areas that we're developing around the sustainable energy solutions. So I think from the documentation and everything that we actually determined at the very beginning of this program, that there's a real opportunity here in Suffolk, especially, to look at developing a clean tech sector. And we want to be part of that program as we go forward. And we're looking to link with companies like Connected Energy to offer practical solutions and teaching opportunity in this area, and the development of further technology to help us achieve a net zero solution by 2025. We've got a number of smart energy opportunities coming forward as well. We have a new smart house or eco lab being developed at Adastral Park, and we're interested in how this becomes part of that formula for delivering on a smart system solution for smart housing and smart cities of the future. So this is quite an interesting opportunity, and we're discussing that with Connected Energy in terms of setting up a small solution at Adastral Park, which will enable us to actually monitor in situ. So it's a real opportunity. We're also interested, and we understand the business case for some of this in terms of the electric vehicle solutions. And actually, as the initial first generation of batteries are starting to come online for Connected Energy, we're interested in understanding how we can improve that opportunity, and how we can look at extending the value of these electric vehicle solutions. So there's an opportunity here to look at a number of those areas. And in terms of future research within the Institute, I said it's domestic district energy solutions and how the battery storage might work, but actually it's domestic and commercial to a certain extent. But we're looking at how people are developing for the future, and we're working over at Adastral Park. There's a 2,500 home development happening right next door with Taylor Wimpey, and we see this as a great opportunity for bringing in micro generation solutions, but actually in terms of protecting and security of the system, actually bringing in these large battery storage opportunities. So we'd like to be able to develop that with BT and Taylor Wimpey in terms of an opportunity for the future. And that's something that I see as key to our research at Adastral Park and with the Eco Lab. I'm really interested as well in terms of, or there are areas that we're in terms of energy decentralization and how this becomes part of the decentralized solution, and the idea of peer-to-peer energy trading and how we can link that and add security through battery storage. So there's a number of areas that we're trying to develop through our business school and through the technical side to look at how these things could work independently. And we talk about the prosumer and bringing benefits of the storage and the distribution. The prosumer being the consumer and producers, actually how can they benefit from holding on to their energy and then putting it back into the grid at optimized time. So there's an opportunity in terms of study there as well. And it's key around, we're also working with a number of companies around demand side response. And it's not necessarily that a battery solution would be necessarily needed in that, but the program enables, not everybody can actually deliver an optimized solution through demand side response, and battery storage could be a key thing as a backup solution to that. So we're key to work with our demand side response technologies and innovators, and actually with Connected Energy to look at the security of storage for that process. And again, the repurposing of the batteries from the electric vehicles, as it's really interesting to look at the next generation of batteries that are coming through and actually how well they perform. So I'm interested in how we can work with Connected Energy to come up with solutions around repurposing these future batteries as they come online. But it's, for me, the key thing at this moment in time is actually how we link with the hold and how we then understand the actual production or the use of the battery system and use it as a research tool and a teaching tool for our students and staff. But it's great to be working with Connected Energy, and I see this as a great opportunity for developing a long-term relationship. Thank you very much. Sorry, have I turned everybody off by accident? No?
I don't think so.
No,
Nigel,
yeah, I'm back again. Yeah, sorry, I was just trying to get back to that screen where I turn everything back on. Yeah, yeah, wonderful, Daryl, fantastic. Thank you for your presentation. It's really, as Matthew said at the beginning, it's really important, both the battery storage project with Suffolk Council, but also with the University of Suffolk, this research partnership. It's the first of its kind, I would say, within energy storage, and it's kind of what we want it to be, really. We've got an open book here, and we can do lots of exciting things. So yeah, that's great.
Well, and it's an aspiration of the university, obviously, to look down the new alternative energy route. So this is perfect for some of the work that we're doing, and it fits nicely with some of the domestic solutions and the smart house solutions we've got going over at Astral. So I'm keen to actually develop that further with you guys. So that's good.
Yeah, brilliant. Okay, so it's now over to me. I'm going to just talk a little bit about the Hold project from Connected Energy side, and then walk through what energy storage is and how it can benefit different organizations. So if I just pull my okay. Yeah, so as Mark has mentioned very well, and also we talked about it a little bit on our video, the whole project was an early adopter of Connected Energy's Second Life battery storage technology. It's a 300 kilowatt system, so that's providing 300 kilowatts of power and the capacity of 360 kilowatt hours. That's provided by 24 Renault Kangoo batteries. So those batteries have already had their first life within a vehicle, which is a Renault Kangoo van. We get the batteries at around year 5, year 6. The range has depleted within the vehicle. We get the batteries tested to our specification, and then we assemble them into our purpose-built container, as you can see in the picture there. That's a standard ISO 20-foot shipping container. We then connect that to our inverters. So there's 12 inverters in that system, and then we have our power control system. So the clever part and the IP of Connected Energy is the ability to control and manage multiple batteries. So as I say, in this system, there's 24 batteries within fractions of a second to be able to respond to those frequency response grid services. So as I mentioned, yeah, Suffolk County Council, they were an early adopter of CE. I've been talking to the council, probably started talking to the council about 4 years ago about the hold and the aspirations of the hold. So the seed was planted a long time ago. It's a flagship project for Connected Energy. With a regional council, we're based in Norfolk, but this council is just over the border into Suffolk, and we've also got this leading 3-year partnership with the University of Suffolk, which Darryl has spoke about. And as Mark said, so we're looking at a triad avoidance. So we're using the battery during that time period, 4 till 7 p.m. Monday to Friday, November to February. And then outside of that, the battery is performing in an aggregation market with an aggregator called Grid Beyond. What Grid Beyond do is they monitor the grid. So we have a control box within our container that talks to our battery, and it also talks to National Grid. And if the frequency of the grid is imbalanced, i.e. there's either too much generation going into the system or too much demand, then the battery storage system can reduce the demand of the site, or it can take some additional power from National Grid and provide Suffolk County Council with a revenue stream through Grid Beyond. So what we did at the outset, which Mark mentioned as well, is we modelled a battery storage system for the demand of the whole site. So it was a predicted demand curve because it was a brand new building, and we looked at other similar buildings. This is what the load profile is going to be. This is the size of battery storage system that is going to provide you with the most benefit. And then on the back of the whole project, this was a catalyst for other projects in the region. So we delivered a project with West Suffolk Council around about similar times, actually, over at the Mildenhall Hub project, which was also mentioned during our video. That project at the moment is doing very much the same as the hold. So it's providing the triad avoidance while we still have triad, grid services revenue, and then in the future, as the video said, it's going to be connecting it to the solar, so it can charge from the solar, and then it can offset that additional load from the air source heat pumps. So I just wanted to move on to the benefits of using a battery. So there's lots of different ways that you can use a battery storage system on your site, and I've highlighted here some of the main kind of ways that you can do that, and I'll talk about them all in detail on the next slides and kind of show some graphical examples. But one of the things that we wanted to mention as well is, we're going a step further here. So we did a joint study with Lancaster University. It was around about an 18-month study where Lancaster looked at the carbon intensity of National Grid and how battery storage working within the grid system, so within that grid services system, like the Hold and Mildenhall Hub are doing. They are reducing the carbon intensity of the grid by enabling additional wind and additional solar to be part of the grid mix, and that offsets gas and coal. So Lancaster looked at batteries within the grid mix, and they then looked at first life and second life, and they calculated that second life system from over its lifetime could save an additional 144 tons of CO2 compared to a first life system. So, we are reusing EV batteries. So we're creating a sustainable plan for our transition across to electric vehicles, but we can also verify that with Lancaster University showing that additional carbon saving. So I just go on to kind of the individual benefits. The one main benefit is EV charger management. So, Mark mentioned that in the future, the Hold is looking to put some EV chargers onto their site. When you bring EV chargers onto your site, then you increase your electrical usage. you may only have a certain amount of import capacity. So that's the amount of electricity that you can bring into the site. So what a battery storage system can do is we can manage that import capacity. So you can see the graph on the right here. If a battery storage system was not there, then this would be your natural site load. So you'd be peaking up at 80 at 2 o'clock. So there'd be a big peak up to 80, and then there's, you know, you're hitting that 40 level again. So what we've done is we've put in a limitation. So you're using battery power, which is knocking off those peaks, and then it kind of maps with our state of charge. So you can see we're discharging down into the site here. So you're using battery power rather than grid power, discharging again, and then we're charging back up, discharging and charging again. So we're knocking off those peaks, which are the additional EV charging load. So we're able to manage the site to an agreed import capacity. We can also optimize on-site renewables. So one of the other things that we're doing with the whole is we're capturing the solar into our battery system, instead of that solar going out to export at a low export contract. So we can see by this graph, we can see how the site energy load has been changed by our e-store charging and discharging. So you can see the light green would have gone out to from 0 downwards. So this would have been exported out. So we're actually capturing the excess energy, and we're putting it back into the battery system. So yeah, so we're charging from the surplus energy generated by the solar, and then we can do that. We then reduce the peaks on site, because these are the peaks from grid. So we're reducing grid usage by storing the energy from the solar into the battery and then putting it back into the site. So this is classed as optimizing on-site renewables. Very similar is reducing peak loads. So very similar to the EV charging model, but this is not EV load. This is just site load. So it could be EV chargers. It just could be plant or machinery on the site, or it could be expansion. So, for example, the archives building at the Hull, they're looking to expand. They're looking to put some new machinery in. We know that will increase their electrical usage, and potentially it could cause breaching. So breaching your import capacity creates fines, and then there's payments that you would need to pay. So what we then do is very similar to the EV charging model, is we put the battery storage system in, and then we can discharge into your site during those times of peak, and we can knock those peaks off. And you can see that there. So the natural site load is the light green, and the managed site load, so the new site load with our battery system, is the light blue. So you can see when we're knocking off all of those peaks again. And what you can do is you can create a predetermined limit. So if we say, again, with the Hold as an example, we've got a predetermined limit of 300 kilowatts or 250 kilowatts. We don't want to go above that 250 kilowatts. We can then use a battery to manage that 250 kilowatt limit and ensure that any of the peaks, the new peaks by any new machinery or EV chargers, whatever it may be, they can be knocked off by discharging the battery into the site. So you're using battery power rather than grid power during those time periods. And the next one is trading energy and generating revenue. So this is very much what the Hold building is doing at the moment with our battery storage system. So there's two services. That we've got the frequency response service. So the power output of our system, it tracks the fluctuations within the national grid. So you can see our battery storage system, where we're monitoring the grid. So we're charging a little bit, we're discharging, we're charging, discharging. So, and that's happening on a daily basis with the aggregator. And then what we try and do is we try and keep the state of charge close to 50%. So that's able to both charge and discharge to meet the demands of the grid. If we're sitting at 50% and grid needs to release some power, our battery can fully charge up from the grid up to that 100%, and then we discharge back down, get back to that 50%. If we then get a call from the aggregator to say, right, we need to discharge into your site to reduce the site demand, then we can drop that down to down to 0. And then I've just shown a graph here, just showing kind of the trading desk of an aggregator. So this is Grid Beyond. Grid Beyond are working with Suffolk County Council and the Hold, and it's just really to show the volatility of the market at the moment. So we've got wholesale trading here. You can just see how spiky it is. So this is cost. So we've got £0 up to £1,000 per megawatt hour. And you can see that the market is hitting those very high numbers quite a lot of the time. So it's, over the last 6 months, there's been a massive increase in volatility. We've got dynamic containment. So this is another marketplace. As you can see, it's averaging out around that £17 per megawatt hour, but it's fluctuating. It's hitting £50 per megawatt hour. Same with dynamic moderation and dynamic regulation. So these are all different mechanisms within grid services that allow you as a customer to benefit. And it just shows the volatility in the marketplace. And this is predominantly down to the decarbonisation of national grid. So we're decommissioning coal, we're decommissioning gas, which are your base load, and we're replacing that with large solar farms and large wind turbines. So wind farms, they are intermittent, so it's not always sunny, and it's not always windy. So that's why you're seeing this this volatility. So in the short to medium term, you need the battery storage systems to be able to charge from the solar when it's sunny, and to be able to charge from the wind turbines when it's a very windy day, to bring that national grid back into balance. So we see there's a huge market here for this trading part of the battery storage system. Also combining it with your site demands, so the ability to manage your peak load, manage your import capacity, the ability to support EV charging. If you have any solar on site, the ability to capture additional solar. So there's lots of different ways that a battery storage system can provide you with some benefit. So that is me. Stop sharing my screen. So I think we're running a little bit ahead of time, but we're now kind of over to Q&A if anybody has any questions.
Oh, there must be some questions.
It's more comments, really. I normally I raise the hand button on Teams, but I'm not quite used to Zoom. I quite like the bit about reducing peak loads, because it's going to be one of the future aspirations at the Hold when tried. So under targeted charging review, triads and duals are disappearing, which Nigel touched on. The new charging mechanisms is going to be via the agreed supply capacity.
Yeah.
So if we can keep, especially as we're looking to install lots of EV charging, if we at the Hold, if we can keep our site load as minimal as possible, reducing the peaks and spreading out the load across the day, there's less strain on the grid, and obviously it will result in cheaper running costs for the council as a whole. So particularly like that. And Nigel, I presume you're showing the slides afterwards, but if you wouldn't mind sending them across as well to me,
yeah, of course.
to have a look. You put it so much more eloquently than me.
No worries. We've recorded the session as well.
Okay, fantastic. The other question was about the study you did about second life batteries and the carbon reductions.
Yes.
Quite keen to capture that. So if you can provide any kind of background info or anything like that, keen to do that, because obviously we're looking at our scope 3 emissions, and I think it would technically fall under there. So keen to kind of explore that a bit further.
Yeah, of course. Yeah, no problem at all. So what we've actually been doing through our LinkedIn channel with Regine is we've been sharing. So Lancaster University did this big research piece that they then provided us with a with a summary and a report. We're disseminating that report into small bite-sized chunks. Okay. And we've now got that on our website, so I can send you a link to that. Also, we've got kind of a summary as a PDF of the report.
Excellent. Yeah, be keen to explore more about that. Excellent. Thank you.
No problem. Yeah. So, well, one of the questions I get asked a lot is, how long can we run the second life batteries? So, second life, the batteries come to us, as I mentioned in my presentation, at around year 5, year 6, and then depending on the application, we can run those batteries for anywhere between 8 and 10 years. So that is, around about 1.7 to 2 cycles per day. So, we are elongating the life of that battery by another 8 to 10 years. And I think the other benefit of second life batteries is the through life costs. So the battery replacement cost in that year 8 or year 9, year 10, it is a very low cost compared to a first life battery, because there's going to be so many of these batteries coming into the system. So in 8 to 10 years, thousands of batteries, that the cost of those batteries to connected energy will be very low, and then that will be a low cost that we pass over to our customers.
It's definitely something we're aware of. We have a first life system and a second life, so comparing the two is something that happens quite a lot, and it's something, obviously very keen to champion, shall we say? So
fantastic.
Nigel, may I ask a question?
Yeah, please do.
I mean, looking 4 or 5 years ahead, what's the vision of what you can do, the scale of what you can do with this project, and what's and what sort of sites do you think you could be providing energy for realistically?
Yeah, really good question. I'm not sure if Matthew's still on the line. He may be able to talk about our kind of aspirations for our M-Store product.
Yeah, happy to do that.
And Matthew, I'll be transparent. I'm going to probably sit and listen to you or one of your colleagues tonight, the presentation you're doing in Latvia.
Okay.
So I'm going to be transparent.
Okay, no problem at all. So basically, we've developed these smaller systems so that the architecture of the system is extremely modular. So the next phase of the development of the business is focusing on sort of tens of megawatt sort of scale systems, because we can put multiple containers on sites, but ultimately we think that the real scale up of second life batteries is not just around the technology, it's also around the business model. So we're looking at a model which is perhaps a little bit more like an energy from waste plant. So you actually have a facility which is developed to process the waste, and you generate energy from that, and obviously the recyclate moves onto a market. So we're looking at a similar system or similar model for second life batteries, where we build a large scale facility, and this is part of our investment round at the moment. Build a large scale facility, and you design that so that batteries can actually flow through it. So you have a contracted flow of batteries. We extract the value from those batteries by providing flexibility or perhaps co-location with renewable generation, wind farms or PV. As those batteries are degraded, we then replace them, feed those onto recycler, and a new set of batteries comes in. So the architecture is designed to be very modular and scalable, but also the next generations are really designed so that we can handle a range of different batteries. Where we think we can be particularly strong in this space is that we control each individual battery according to its merits, its temperature, its state of health, its state of charge, etc. And if you can imagine, as those batteries flow through the system, the configuration of batteries will change. We'll have batteries of the average level of degradation, the type of batteries will vary. And what we're working on at the moment is using artificial intelligence to really understand the batteries and understand better how we can aggregate the batteries in different ways to fully capitalize on the value of the individual batteries. And obviously those batteries, we will buy them at different prices, or they'll provide us as a service at different prices. And therefore we want to capture the best value from those individual batteries. So yeah, so our view is that given the volume of batteries that will become available, you really need to move up to much larger scale systems that will be co-located alongside renewable generation, providing flexibility services, providing resilience into the overall energy system. Does that make sense?
Yeah, that's great.
There's a question in the chat.
Yes, I've
Matthew,
seen
you
that.
mentioned about scale up. Do you want to talk about scale down as well?
Yes, yeah, no problem. So that's something that so Connected Energy started. Some of our smaller systems were actually 60 kilowatt hour, 90 kilowatt hours. Sorry, yeah, 60 kilowatt, 90 kilowatt hour systems. And we've got a couple of those systems with Dundee City Council and a couple overseas in Northern Europe on a couple of motorway services. What we found though is half of our container is our fixed costs, which are our power control system, our inverters. That fixed cost is fairly similar for 60 kilowatts compared to 300 kilowatts. And because we're using reasonably small batteries at the moment, so when the batteries come to us from Renault, they're 15 kilowatt hours. As and when we start to see bigger batteries coming, so 50 kilowatts, 100 kilowatt batteries from buses, trucks, then there is potential to start going back down to that smaller scale, because if you've got a much bigger battery, then potentially we only need one inverter. So our fixed costs will dramatically reduce. Whereas as we are at the moment, that for us to manufacture a small system compared to a 20-foot container, the kind of economies of scale are much better for the 20-foot system.
Can I ask a question, please, Nigel?
Yeah, go for it.
As you go through your 8-year cycle, and after that cycle diminishes, you're going to find that you'll have a lot of batteries that you would need to look to recycle yourselves. Have you got a plan or a business plan of action in place to look at? I mean, it comes to mind because of the rare earth recycling that the Royal Mint are doing and things like that. The opportunity with these batteries, and there's quite a lot of valuable material in them, and what you intend to do with that in the future.
Yeah, fantastic question, Daryl. Yeah, so we're working on a project with UK BIC, the UK Battery Industrialisation Centre, called Recovas. And that project it's doing a number of things. One, we're looking at creating a passport for every EV battery. So when the batteries come out of their manufacturer, they get stamped. When they go into a vehicle, they get stamped. After they leave the vehicle, they get triaged. If there's life in them, they'll come to us or another battery storage manufacturer. If they've been damaged, then they'll go to a recycler. After we've had our life with them, then we're creating that supply chain for the third life. So pretty much every university in the land are looking at EV batteries and what else we can do with those EV batteries. So there could potentially be a third life. if there's not a third life, there are recycling facilities being built as we speak in the UK. If we have a battery storage system where the batteries need to come out now and those batteries are filled, then they would go back to Renault in France. But the future is to have a supply chain in the UK to be able to take those batteries either to be recycled or for a third life application.
I'll just answer that if it's okay, because it's quite
important.
Of course. Because what we're increasingly doing is working with sort of strategic partnerships with battery suppliers, and those are largely OEMs, but also some companies that are financing fleets and ultimately own the batteries. And obviously, from a carbon perspective or a sustainability perspective, we're really keen to deploy the batteries in a storage system as close to where they were deployed on the road. And similarly, we're keen to then recycle them as close as possible to where we're using them. And we're doing a lot of work at the moment on trying to do what Nigel's described, which is linking the whole value chain. So at the moment, we don't have an immediate requirement for recycling. But we're working with a number of parties that are looking to enter into the UK and build recycling plants so that we've got some options. But also, our objective in life is to maximize the value of the embedded resources in those batteries. That's our purpose. So we'll be really looking to try and partner with whoever can extract the most value at the recycling stage as well. So the most efficient recycling processes. So also really keen to work with any universities or commercial partners that are really focusing on optimizing that recycling process and maximizing the value there. So it's a really tricky phase of the industry because the batteries are just starting to become available. So we're able to scale up our business as the batteries become available. And also, there are a lot of recyclers looking to build plants in the UK and Europe and elsewhere, but are just waiting for that flow to build up to, provide a robust basis for their business models as well.
Thank you. Well, no, I'd like to get a couple of batteries eventually if I could, so I could just take them down and look through them.
I think we might have a couple we can spare.
Yeah. Wonderful.
Just one more question. You mentioned a couple of times Renault batteries. I mean, is that just because they're a business partner, or, being ignorant in these things, or a battery is a battery is a battery? When you do this, you could stick into one of your containers, I don't know, 10 Renault batteries, 10 Ford batteries, a Lada battery, or whatever else.
Yeah. Good question, Gordon. Yeah. So one of the reasons for Renault is, they moved in France, Renault moved their postal fleet across to EVs, some years ago. So it's the availability of the EV batteries, but Matthew and Pete, our CEO, are talking to pretty much every OEM, where we are doing some tests with other battery manufacturers. So yeah, as you say, Gordon, we can pretty much talk to any battery. So as long as there's volume there, then yeah, we can work with them.
Renault put them themselves in a very strong position for Second Life, because they started off by leasing the batteries. So they have really good visibility on what batteries will be available when, they own them, so they can control them. They can pull them out of fleets a little bit sooner if they like to. But ultimately, they were able to provide us with a projection on what that battery flow is like to look like, and also because they've got quite good data on how the fleets are being used. Also, quite good visibility of the state of health of the batteries when we received them. So they were the ideal partner to start off the business, but now I think a lot more OEMs are starting to see Second Life as an opportunity rather than the batteries being a liability that they just want to get rid of, and now really engaging with us to sort of form more strategic partnerships. Just in terms of you touched on the interchangeability of the batteries, so when we build systems that have got a range of different batteries, we will, if you like, have channels of a particular type or particular class of battery. So our control system can control batteries of all sorts of different types of manufacturers, but they have different form factors and different cooling systems. So there's an implication in terms of the cooling and the racking and just the space required to house them. But actually the control side is quite simple for us to do, because we started off with that philosophy of being battery agnostic right from the beginning.
Yeah. Brilliant. All right, guys. Well, we've hit 12 o'clock. Any more questions that we're going to squeeze in before the end of the session?
I have an observation. Is my only.
Go for it.
I just I think from my point of view, it's just really exciting to see this collaboration come alive. It's really great to see things happening in Norfolk and Suffolk, developing that public-private education partnership, and because that's all what we're about as an organisation. So it's really exciting. Everything around clean growth and the circular economy that Matthew alluded to is just really exciting for our region, and it's really great to see it here. And just a minor point on the hold in particular, we provided a little bit of funding to support that project as well. But I think from my perspective, it's been great to hear much more about the project, and thank you very much, guys.
Yeah, wonderful. I think as the partnership with the University of Suffolk develops, we'll be able to start publishing what we're doing. We can maybe do some seminars and webinars and outreach as well, Darryl, once the program gets started. Yeah, I'd just like to say thank you on behalf of all of the speakers. Thank you for Ellen and New Anglia LEP for supporting this and kind of co-hosting and helping with the outreach. We'll send a copy of the recording, a copy of everybody's presentations if they're happy, and also we'll send a link to our video. And yes, thank you very much, and everybody have a nice lunch.
Sorry, can I just quickly say something?
Go for it.
It's not a plug, but it is.
Yeah.
We're working on a community renewal funding program with New Anglia LEP and a number of, and I believe that you're coming along anyway, Nigel, to do a talk on the April the 22nd.
I am, yes, yeah, definitely.
It's a face-to-face opportunity for people to come to the hold, and actually they could get a sight of the Connected Energy site and the hold itself and how it's working. So it'd be really nice for people. I am plugging it, but I'm not plugging it. But I thought it'd be a good place to say.
Darryl, I will make sure the attendees get the Eventbrite details.
Thank you very much. That's great, Ellen.
Perfect.
Thank you.
All right, thanks, guys.
Okay, thanks everybody.
Yeah,
Thank
cheers.
you very much. Thank you. Bye-bye.
Bye-bye.
Bye.
Cheers, guys.